In the previous classes, we have seen the different wastewater characteristics. In that, we have seen physical, chemical, and biological characteristics. In that, the chemical characteristics we have specifically seen regarding in detail regarding BOD. Okay, now this BOD is going to be very important aspect for you, because again the theory will be asked on this, or again either the expression of a BOD first order expression may be asked to you in exam, or the problems will be asked to you in the exam. So in today's class we will be solving the first order BOD expression along with some of the problems. In the previous class we have discussed in detail regarding what is BOD, how the BOD is related with the temperature, how BOD is related with the DO, right? So all these things we have seen in the last class, and why BOD is a very important aspect, that also we have seen. BOD, as the higher the BOD value, higher will be the your or the concentration, the concentrated will be the wastewater. Okay, so now we will be straight away will be discussing regarding the first stage BOD expression. As I have told in the previous classes, right, the BOD is going to have the two types of BOD is there. One is CBOD, and the carbonaceous BOD and the nitrogenous BOD. Okay, now we'll directly we will be going to discuss on the first stage BOD expression. Okay, now we will see what is the how the BOD expression can be done. Okay, now at a given temperature, the rate at which the BOD is going to be satisfied at any time may be assumed. Okay, it is directly proportional to the amount of organic matter present in the sewage. Okay, now the BOD exerted, okay, is at a first order is given by dLT divided by dt is equal to minus k dash into LT, where LT is nothing but the BOD is going to be exerted at any time. Suppose BOD is going to be exerted for after 5 days, so LT is nothing but going to be L5. The L5 value will be after BOD exerted within the after 5 days of time. Okay, might be it is 2 days, 1 day, 3 day, or whatever the time period the BOD value it is going to take, that is nothing but LT. The BOD at any time t, 1, 2, 3, it is going to vary 1 day, 2 day, 3 day, 5 day, whatever it might be. Okay, then K dash is nothing but the rate constant satisfying the rate of oxidation of organic matter with having the unit per day. Okay, it is to the base E. Okay, then T is nothing but the time in days. Suppose if it is BOD exertion is going to take after 1 day, 2 day, whatever may be the date, or whatever might be the time, that it is nothing but the time in days. Now integrating this equation, the above equation, right, we are going to with having the limits t is equal to 0 and t is equal to t, we are going to get it as dLT divided by LT is equal to minus k dash into dt. Okay, now if we have the log of this, then we will be getting log E divided by LT divided by L naught. Okay, then is equal to minus k dash into t. Then it is going to be, we are going to get, if we simplify this, we will get LT is equal to L naught. If we take log this side, it is going to become E minus k to the t, or it will become, right, 10 to the minus power kt. Okay, 10 to the raised to minus kt, where the value of k will be equal to k dash divided by 2.303, where k is base 10 rate constant and k dash is base E rate constant. Okay, now if we simplify this particular equation, right, if we simplify this particular equation, we are going to get the amount of BOD remaining at any point at any time t, okay, is given by, just we are going to simplify it. What will happen? LT L naught will go here, so LT is equal to L naught into 10 to the power minus kt. Okay, then the amount of BOD exerted at any time t is given by, okay, the amount of BOD exerted at any time t. Means suppose if the BOD is going to be exerted after the period of 2 days, 3 days, 5 days, whatever might be the date, then the amount of BOD is given by yt is equal to L naught minus LT. L naught is here, L naught is nothing but the ultimate BOD. This we need to remember. L naught is nothing but the ultimate BOD, the end BOD. Okay, while telling you the theoretical part, I have told that the BOD, it is the exertion of the BOD will be done at after 20 days. So around 99% of the BOD will be exerted after 20 days. So ultimate BOD L naught is nothing but the end BOD or the ultimate BOD, the final BOD, and LT is nothing but, right, LT is nothing but the BOD at any time. So the amount of BOD exerted at any time will be the ultimate BOD minus the BOD at any time t. So the BOD at any point t is given by L naught minus LT. So here as LT, right, we are having the expression for this. LT is equal to, okay, we are going to have the expression LT is equal to L naught minus L naught into 10 to the power minus kt. So if we just apply here L naught minus and L naught minus what will be LT? LT is nothing but L naught into 10 to the power minus kt. So we have taken L naught as a common, and then we have taken L naught into 1 minus 10 to the 10 to the power minus kt. Okay, now here this is your the BOD at any point or after time t will be given by this particular formula, that is BOD at any time t, yt is equal to L naught into 1 minus 10 to the power minus kt. Okay, so this is the formula that we will be utilizing when we are going to solve the problem, where k is nothing but the rate constant, right, and t is nothing but the time in days, okay, and L naught is nothing but the ultimate BOD, and the Wi-Fi is nothing but the BOD at any time. So you need to remember this BOD at any time, given time. Suppose if you in a problem they have given, right, determine the 5-day BOD, so this will become Wi-Fi, and the ultimate BOD value if they have given, right, then you need to add it over here, then the t after how many days, whatever the value they may be going to ask, right, so that we are going to determine, and normally the k value will be given to you, or if not given, how we need to solve it, that we will see it. So for example, 5-day BOD is given by Wi-Fi is equal to L naught, right, Wi-Fi, I have told Wi-Fi is equal to L naught into 1 to the power 1 minus 10 to the power minus 5k. Why 5? Because 5 days, here t we have replaced it with 5, t we have replaced it with 5 because t is nothing but the time in days. Now we are going to have one more relation between the kt and k20. The rate constant, it is completely dependent on temperature. Okay, so now in order to find the k at a different temperature, right, we will be using the formula kt is equal to k20, right, kt is equal to k20 theta into t to the power minus 20. So again this formula also we will be using when we are going to solve the problems. Okay, so this formula and this formula we will be normally be utilizing. Then now as the rate constant k is dependent upon the temperature, then the theta value will be equal to 1.056 if the temperature is going to vary between 20 to 30 degree Celsius. I repeat, this theta value, right, as this k value is dependent upon the temperature, if the temperature is going to vary between 20 to 30 degrees Celsius, this theta value will become equal to 1.056. Then the theta value will become equal to 1.047 if the temperature is going to vary in between 4 degrees Celsius to 20 degrees Celsius. So we need to remember these two values, right. Normally in problems and all you will be getting this, right, but again you need to remember this also. Okay, now we will be using this formula as well as this formula, along with some more formula. We will repeat it, what are the different formulas that we are going to use when we are going to solve the BOD problems. Okay, so we will be solve formula to be used in BOD problems is BOD is equal to oxygen consumed into the dilution factor. See, the oxygen is consumed. I have told how the oxygen is going to be consumed when we are going to have the BOD in our theoretical class into dilution factor. Dilution factor is equal to this. Also, we have already seen in our theoretical class. It is equal to volume of the diluted sample divided by volume of undiluted sample. So if we multiply these two, we will be getting how much is the BOD value. Then BOD, that is BOD at any time, is given by Wi-Fi is equal to y L naught into 1 to the power minus 10 1 minus 10 to the power minus kt, where k is nothing but the rate constant, t is nothing but how much time it is going to consume, that is t in days, k is nothing but the rate constant, and L naught is nothing but the ultimate BOD, and yt is nothing but the BOD at a given period of time. Now, just now we have discussed, in order to find the rate constant, which is going to be varied dependent upon the temperature, in order, if k value is not given, if the rate constant value is not given, so in order to find out that, we will be using this formula, that is the kt. Suppose k30 value is not given. Okay, suppose k30 value is not given and k20 and the temperature variation they have given, then we can find out the rate constant at k30. That we will be seeing in detail when we are going to solve the problem, and along with that we are going to use the formula k is equal to k dash divided by 2.303. This is to the rate constant to the base 10, and this is to the rate constant to the base e. Okay, so this again, this relation also we need to remember when we are going to solve the problems. Okay, so now right now we will solve some very simple problem in today's two problems in today's class, and then we are going to take one more class in order to solve the problems on BOD. Now we'll solve a very basic type of a problem in BOD. In today's class we will solve very simple problem on BOD. Okay, so I'll read it and then we'll see. In order to conduct a 5-day BOD test, okay, then the sample of wastewater was diluted with the specially prepared diluted water with the dilution factor 150. Okay, now what is given here? Dilution factor is given. Now the DO content at beginning and at the end were 100 mg per liter and 7 mg per liter respectively. Okay, now compute the 5-day BOD. Okay, so this is your problem. What they have told in the problem is, they have taken the wastewater and it is going to be diluted with the specially prepared water having the dilution factor 150, and the DO content at the beginning and at the end were 11 mg and 7 mg per liter. Now they are telling you to determine the 5-day BOD. So formula for 5-day determination of 5-day BOD is BOD5 is equal to oxygen consumed into the dilution factor. Now initial, how much was the DO at the initial stages? It is 11, and at the end that is equal to 7 mg per liter. So here from the beginning to end, what is the difference we need to calculate? Because from 11 it has dropped down to 7. So how much dip is there, or how much the oxygen has consumed from the beginning and at the end? Regarding the DO, how the DO is going to vary along when the microbial content is going to increase, that I have already told you in your theoretical class. So this here, what is happening, the oxygen is getting consumed over here. So from 11 it is dropping down to 7. So 11 to 7, how much amount of DO is consumed, or dissolved oxygen is consumed? That is 11 at initially minus 7. From 11 it is going to drop to the 7, multiply by dilution factor. Dilution factor is already given in this problem. So you are multiplying it by 150. So 11 minus 7, it is 4 into 150. So it will become BOD after the end of 5 days, you will be getting it as 600 mg per liter. So this is your first very basic type of a problem you will be solving in your exam. Normally either your expression will be asked or the problem will be asked in your main exam, that is for sure. So you need to give concentration to both. Okay, Now we will see one more problem, very simple, similar and a simple problem. 5 ml of wastewater was diluted by specially prepared water in a 300 ml capacity BOD bottle. Okay. Then the DO concentration of a diluted sample at a beginning was 9 mg per liter and 6 mg per liter after the 5-day incubation at 20 degrees Celsius. Find the BOD of a raw sewage. Again, they are asking you the BOD at the end, right? What is the BOD at the end? They are taking the wastewater and they are going to dilute it. Now again, the same formula you will be using in order to solve the BOD problem. But the thing is, here you need to find out what is the dilution factor. Okay, and the volume, for that you will be using the formula dilution ratio is equal to volume of the diluted sample to the volume of undiluted sample. Now the 5 ml of waste water, they are adding it into the 300 ml BOD capacity. Now what is the volume of the diluted sample? The diluted sample will be 300, which is already given. Now volume of the undiluted sample, the waste water, they are going to add it into this 300 ml. So volume of the undiluted sample will be 5 mg per liter. So what is the dilution factor or a dilution ratio? 300 divided by 5. So you are going to get it as 60. Now loss of DO, it is straight away it is going to drop from 9 mg per liter to 6 mg per liter after 5-day incubation. So oxygen consumed, DO consumed is 9 minus 6. Okay, it is 3 mg per liter. So BOD is nothing but the oxygen consumed multiplied by dilution ratio. It will become 3 into 60. Okay, 3 is we have calculated loss of DO, and the dilution factor we have calculated 60. So BOD 5, it is nothing but 180 mg per liter. So in today's class we have solved one expression and very two basic type of BOD problem we have solved. In the next class we will be using the BOD formulas, and then we will be solving the problems on BOD. Okay, so this is what we have discussed in the today's class. Thank you.